Now that we've proved the different sum and different identities, we are going to use those new identities in verifying. So I'm going to start off with a couple more basic ones. The key here is seeing that you have the two different values. So what I did on the side of this proof here is write the identity that matches up, but you should definitely take out your identity sheet and match up the identities that will work for these. If you see that you have one of these identities, your next step will be to expand out using that identity. So our A here is x. We'll do sine x cosine pi minus cosine x sine pi. Let me just fix that a little bit. Now then what's important for these, what you may have to do is find some basic exact value information here. Could be with quadrantals, could be some first quadrant angles. Remember, you won't have your calculator for this, for any of the proofs, but these are ones that you should know. So then we'll evaluate, and you want to show what your answer comes out to be. So we'd have sine x times cosine of pi is -1 minus cosine x times 0, because sine of pi is 0. And then that would simplify into negative sine x is equal to negative sine x. These will take up more space horizontally, so you might encroach on the space of the other side a little bit, but that's okay, as long as you are clear of which side you're working on. Now let's take a look at another example. This one will be a little bit more steps because it will have a fraction. Cosine of x minus y over sine x cosine y is equal to cotangent x plus tangent y. So again, off to the side, I'm just going to write down which identity I'm going to use. We'll use the cosine of a minus b is equal to cosine a cosine b plus sine a sine b. So although we probably talked about this when we were proving these identities, with the sign of these identities, the middle here is the same. So the positive or negative sign, but the function values like the sine, cosine are opposite together. And then for the cosine version, this is different. It goes from negative to positive, but the trig functions themselves are grouped together. So just some things to think about when you're trying to memorize these identities. All right, so let's expand this. If I expand, I will get cosine x cosine y plus sine x sine y over sine x cosine y. Now when you have this situation, if you look on the other side, you have two parts here. So we can split this into two separate fractions and then simplify. You would need to show this step, and then you have to be careful how many steps you show when you are simplifying. Because remember, you want to do one identity or reason at a time if it's not necessarily an identity. So when I do my next simplifying, instead of using an identity first, I'm going to simplify and cancel out. I don't like crossing off, so I'm just going to box off what's canceling out here. I'll cancel out my cosine y's and my sine x's so that I'm left with cosine x over sine x plus sine y over cosine y. So the reason for that step that I highlighted in blue would be simplifying. And then our next step, we can change cosine over sine into cotangent using a quotient identity. Sine y over cosine y changes to tangent also for the same reason, quotient identity. So you would be allowed to do those both at the same time. And for the same reason, you were able to do the blue step and the simplifying at the same time as well. Now just be careful at this step here when I went from here to here. You're only allowed to do that because there was one term in your denominator. If there are two terms, you'd have to separate it out completely, and that might not always be the best way. But in this case, that was a good way to approach this. Right, this next one's very similar to the first one. We'll take actually a lot of horizontal space, not too much vertical space, so just save your room going across your paper. We're going to expand using each of the identities. I'm not going to write these off to the side because I don't have space, but make sure you're using your identity sheet when you're looking to expand this. This will be cosine x, cosine pi over 6, plus sine x, sine pi over 6. And then we'll expand. That's just the first one, all of this right here. And then the second one will be expanded into sine x, cosine pi over 3, minus cosine x, sine pi over 3. And that entire thing is expanding out the second part. Now we can evaluate each of the parts. Cosine pi over 6 is root 3 over 2. Sine pi over 6 is 1/2. Cosine pi over 3 is 1/2. And sine of pi over 3 is root 3 over 2. And then looking at what we have so far, this term and this term here are going to cancel because they're subtraction. And then the two middle terms will combine together to give you sine x. So since that's really just combining like terms there, we're actually done at this point. It's a little hard to see or going back to what the other side was because I did over encroach on the space. But those are 3 examples so far of what you can do with the sum and difference identities. And I'm going to stop here. We'll look at a second video for a few more examples.